Thank you very much, everyone. Let's now move to the discussion. So first question, I would like to have a quick one. So a lot of you were talking about, the things that the digital fabrication and computational design is bringing into the way we design things or we used to design things. So I would like you to speak to that very briefly, like in 1 minute, like just name a couple of things. Like there are people who are thinking, well, okay, it's complex geometries, beautiful geometries, but like what is the actual significant addition to the design and fabrication processes? You, David, said integration, and then like new forms of expression. Could you just all kind of like in a very short statement elaborate on that? Like just 1 minute each. So let's start with David. Maybe let's keep the order of the, and then we're gonna mix a little bit later.
I mean, for me, is managing complexity.
Managing complexity. Okay.
So I think that's what digital can really do is allow us to look at things that would have been, as Mark sort of suggested, you have so many pieces, so many things that otherwise should have been just so cumbersome. And I think, we seem both Nicholas and Ben sort of show very clear applications where without really that level of understanding and that level of integration, it wouldn't be possible. The one thing I will say that digital doesn't do is it doesn't really make a good design necessarily. I think you really need to have an awareness of what is it that you're trying to achieve. You have to have an awareness of what sort of tactile effect this project will have. And you can't really do that without sort of a really comprehensive engagement with materials. And you can see some of the projects here, kind of a good evidence in all the speakers that, is that moment when you're looking at the sample, when you're working with it, you're actually really having that back and forth that makes it possible.
Great, thank you. Ben?
I would have to agree, but so for us, the process is always incredibly important to manage that complexity. Understanding the material constraints is integral to the process and how we actually start to think about what we can actually do with a material to create a form. So we might start with a complex form, but then as we work through our process, finding materials and understanding how things are fabricated, it becomes integral towards how we can fold in processes of information into the how we communicate design, how it can achieve that level of complexity and end result.
Thanks. Mark, what about you?
Okay, I'll be much shorter than my presentation. For me, I would say that it's about rational thinking and kind of the distillation of the concept itself. So, the whole argument about form follows function. In this case, I would actually say that it's a function that creates good form.
Yeah.
In some cases, when it comes to digital fabrication, because there's a certain elegance in as David kind of showed in kind of cellular structures, let's say if nature is an example, but even in just the limitations sometimes of a machine can actually really make beautiful things, as you could see in the Bar Raval example, if you just use them in the right sequence or set of layers. There's a sense of kind of creative adventure that can happen in that regard if you think about that up front.
What about you, Nick?
Yeah, so one thing that I think is really interesting as someone that many, many years ago took off my design hat for a fabricator hat, which is that architects are using these principles and these tools for design. And then I am generally speaking using them for problem solving. So we use computation on the back end. I mean, to the simplest degree, even we had a job where there was a bunch of repeated pattern, and just the load of a massive repeated pattern on our computers within our company was so high that we developed a script that turned that pattern into a block, whatever the smallest repeated element was, and then created a script that would allow us to work with these huge patterns using blocks, and then a script that would, at the very end when we were ready, would overnight export all those blocks into images, convert them into files, so that I don't have a person spending and that's what we had. We had somebody spending 12 hours unpacking these files for the CNC. And I said, why are we doing this when we have these tools that can solve them? So I would say that the ability to turn 10,000 parts into 18 parts, which is something that happened on the Partisan's job at Gusto. And then I'm not using it for design. What I would say is computation for me is a problem solving tool. Anything where I have to do the same thing over and over and over again, my first question is, can I make a script for this? So that's my input on that whole thing.
Okay, great. Before we move maybe to another question, I would like just to go back to David, and like, or you can also, all of you can like respond to this, but like, are we sometimes creating too much complexity with those tools? Like, you know, because a lot of people are arguing that maybe the stuff that we're creating, it would be perfect for like extreme environments, like, I don't know, like Mars or like space ships, right? But do we need them here in everyday life as human beings? Some people say yes, because we're creating more resilient environments, right? But like, it's like, how could you respond to this? Like,
are we creating things that are too complex?
Yes, and or are we creating things that are resilient, for example? Do we really need that complexity? Is it just for fun, or is it just for the sake of beauty?
Well, I mean, I think this depends on which scale you want to work with. I mean, the centro de Monde Arab is one example that always sticks out as, you know, we can increase complexity in places through just pumping more mechanisms, more components, more complex geometries, and we might have results that are compelling for a while, but they don't have sort of that longevity, right? So I think a lot of the work that I try to do is actually looking at using complexity at the material scale so that we're not relying on this over mechanization of systems that have sort of in many ways proven that is kind of unappealing. I think it's the same thing with design, right? Like, I think if we have sound design ideas and kind of critical analysis of what the problem that we're trying to solve, any technology that we use is just, we're just leveraging towards good design. And I think that's the most effective way. I think what you might be referring is when we kind of get overly excited that something can be done and we don't question why is it that we just need to do that? Why are we just being driven almost by it, right? And it's almost like, well, I get 3D printers, I'm gonna 3D print everything. It's like, well, that's really not, or, you know, and we have had those stages with everything. So Grasshopper a while just become this complex formal space that wasn't really feasible to be materialized, and you know, some of that is being clearly demonstrated by the panel as exceptional application of these technologies. Yeah, so that's my perspective on it.
Okay, that's interesting. So kind of like from this potential or over complexity, this kind of like simplicity is emerging, right? Actually, and resilience in a way.
Yeah. Anyone who's ever answered that question because we can, just look at Disney. Like, I honestly, like, I think this is what we try to avoid as architects, even like really good fabricators. It's the same thing, right? Everything has a purpose. That was my point of the function follows form. It shouldn't just be because we can. That should never be the answer.
Yeah, I always say that each of these jobs that you see today were all done on a budget, and a smart manager is going to ask the question early on, can we accomplish the same thing a simpler way, using fewer parts, using, you know, and then if you're just blindly spending the money, you're not going to last for long, either as an architect or as a fabricator.
Absolutely.
So traditionally, architects have been, you know, once removed from the materials and the tools that are generating architecture. What would you recommend? I'd like to hear from all of you. What would you recommend for designers or architects that don't have access to these tools or these materials to learn how to implement or use digital fabrication? Any thoughts on? Oh, and we have a poll here. We ask everyone to participate. Have you ever made something with any of the following materials? So you can answer more than one response. We're interested to hear how many people are actually making. So maybe we could start with Mark.
So you're asking me?
Yeah, just the question. The question is, you know, if we don't have access to fab labs and within our offices, and we haven't had the experience of actually making ourselves, how can we, you know, leverage this digital fabrication?
So,
what ways?
Yeah. Okay, I got it. Yeah, I would say, you know, digital fabrication sounds fancy and cool. but it kind of starts with like manual fabrication, actually, to be
Mm-hmm.
honest, to understand what the machine actually does, because the machine is only doing what a human can do automatically, right? So it's just essentially saving us time, and in some cases, you know, as Nick has stated, it doesn't actually save us time because it has to think so hard that it's actually slower than what a human can do with his own mind, right? And so I would say that me personally, what has actually taught me the most is actually experimenting with my hands, with materials that are accessible. I mean, forming is easy. If you buy a bag of concrete and you mess around with some forms and whatnot, you can play with that. You can do all kinds of crazy things with that in terms of making your own kind of like pre-tensioned forms to be able to layer different material textures on top of one another. You can use fabrics and things like that. For me personally, it's always been the way that I learn is by actually doing something. And for someone to kind of take that layer of interaction and intimacy out of the physical process, for me, kind of removes you from understanding what the material, what the capacity of the material is for manipulation. And I think, like, I truly believe to go back and, like I was joking before when I said, you know, because we can, that's how you get Disney. But there's kind of a kind of, I think, sincere reality in that statement, in that, you know, I think I personally feel that materials should embody the form that is their kind of greatest advantage, right? And so we shouldn't just be manipulating things. And I mean, in some cases you can make a statement. I mean, art is art, right? Sculptures, what have you. But I think architecturally, you know, we do things for performance factors. So if you look at some of the work that's coming out of Zurich, ETH, with their kind of concrete investigations and using 50% less mass for 100% strength, right? These are the sorts of things that are like sincerely impressive, because it reduces the carbon footprint, it reduces the amount of material, and it creates the same equalized strength. That is the sort of area where I think, like, you know, if you want to learn and you want to investigate, I think you got to get your hands dirty and mess around and break things and figure out what doesn't work. I can't even tell you how many times I've created a script where, if we're just talking on the computational side, never mind the building side, where I've totally broken the whole thing so many times and not realized until you don't actually fix anything until you break it. So.
The Mark, that's a really good comment, and I think the Block research group at ETH, I think is worth not just looking at the work that they're doing now with concrete casting, but look back at when they were doing literally bolts with mud and just masonry physically without any sort of, I mean, they had the computation to they have Rhino Bolt and they developed some of these tools, but it actually comes from them really understanding the geometry and the physical principles, then build a computational. And if you look at the earlier projects, they were then hammering them, you know, destroying them physically, really getting on it. And that sort of, I think, is fundamental in sort of building that expertise to a point where now, yes, you have complex FEM systems to do it, but you know, there's no substitute for really engaging with it. And I can say from my experience, you know, I was a general contractor for 3 years before I went to undergrad. And you know, now I'm finishing my doctorate in engineering, and I still think the most architecture I ever learned was actually being a contractor and, you know, understanding how you put sheathing on a barn, how you build trusses, how you lay them up. What does that really tell us about the interaction of materials, the process of assembly, and all of that information that, you know, a digital model will never really tell you. It's only the experience of really understanding how the sequencing of a project will actually make it possible.
And I think understanding like how, when you do start working with the material and breaking it down, you actually break it down into its simplest components a lot of the times, just understanding the basic moves of what you can do. And that really can start to feed into how you might build a script, or any kind of parametric modeling is based on simple parts, and it becomes additive how you actually link things together, and sequencing and process all play into that. So much of any parametric tool that we might be building starts with a simple one-to-one relationship of part to part or move to move. And a lot of that can actually factor into how we can actually make things more ecological. If you if you understand form as being just embedded information, and us as architects being the curators or the who actually decides what information gets folded into form, you can actually make things smarter in a way. Just understanding the process is important and part of that.
And then I would also just add to a couple good pieces of advice that casting is a great way to do stuff at home. I would actually also argue that aluminum and brass and bronze in high gauges, which is to say small thicknesses, are easy to cut with shears, easy to make to bend on homemade brakes. Origami and paper sort of modeling and maquettes can very easily be transitioned into aluminum or brass maquettes. Things like cables and anything that is soft enough to be bent by hand, anything that's like a soft wood like basswood, like you can have a couple of small hand saws and a softer wood, and you can really go nuts. Again, I would recommend that all architects are doing this material investigation internally. I know Partisans has a really interesting thing where they're trying to roll metal using some like VR goggles, and then rather than outsource that to me, which would be happy to do, and we also are doing this, they're actually they bought a little machine and they have the head goggles, and they're just sort of, certainly they're not the experts in how to even use the stupid thing, but they're doing it anyways. And so be ambitious and go out and buy the tools. Obviously not everybody can have a $500,000 CNC, but you can make things, you can do things, you can do a lot in your garage, basically.
I'll just say the best $500 to $1,000 you could ever spend would be on a cheap laser cutter or even a cry cut to be able to sheet feed in some things. Because that whole ability of cutting two-dimensional sections and using those as assembly parts teaches you so much about the sequence of assembly and how two-dimensional planar objects can become three-dimensional, that it's unbelievable how that opens your mind.
Exactly. And remember, it's all coming as sheet goods. So the second that you decide you're not purchasing sheet goods, you've just quadrupled the price. Exactly. Period. I mean, there's no way around that.
And waste.
Yeah. Exactly right. Exactly right.
And you've been like saying like architects should start experimenting and stuff like that, but like I recently read a quote by Norman Foster, and he's talking like historically architecture and engineering were in a symbiotic relationship, right? And like I was thinking is in context of digital fabrication, and it made me think that maybe now, because of digital making and digital, and computational methods, maybe not only architecture, engineering, but also construction is kind of forming this symbiotic relationship, right? How can you speak to that? Like, like what's the role of structural engineering and constructor in the entire process, right? Or is it more close? Does it mean like closer relationship? Because, even a lot of things that you were showing, like you were talking about like their structural properties, right? Or like looking into material programming. It's very important.
You're talking to me?
Yeah.
Oh
yeah, exactly. Let's start with Mark. Yeah, this time.
Sorry. Yeah. So yes. So there are a number of factors that contribute to this, but I'm just going to like throw out 3 letters. IPD. Okay. Mm-hmm. So obviously there are a number of reasons why this is becoming a very popular, let's say, contractual method of delivery. And many of which are like quality, certainty, let's say. These are words that come up, value, and it's a very different model where it's like kind of everybody has some skin in the game, right? So your incentive to actually do better, in theory, is a lot higher than it would be if it were like a traditional kind of stiff sum contractual model. What I would say is that if you look around and you see firms like you're talking specifically Foster's, even our firm HOK, what you'll notice is that a lot of these firms, they're not just architecture firms. They have mechanical engineers. They're like complete, like full-on mechanical engineering firms, structural engineering firms, us included, right? And the reason that we do that is because we've realized that it is that tightly integrated. And so if you want to actually have a solution that where everything is kind of integrated with the next thing, and you've got mechanical concealed in envelopes and whatnot, then you've got to have those people to be able to contribute, because it's not just enough to design something. You've got to validate it and be able to make it right. And you've got to be able to simulate it as well. So there's a whole process of chain of events that has to occur where you need so many different players in the team, where arguably one of the most important parts is that there's a whole bunch of theory that can be done up front, design work and let's say simulation. But then there's the whole component with like involves fabricators, where you're doing scaled mock-up. Right, so you've got varying different scales of mock-up, different amounts of complexity with electrical, and then with airflow, and again, like some of the stuff that you know, Nick was showing with the machining, where, you know, just I love the anecdote because I've been in the same circumstance where, you know, like the bit starts to pull itself out of the machine, right? And in one case, it was a saw that got stuck mid-cut. These are the sorts of things that when you're doing something that is incredibly and overly ambitious, and it doesn't happen across a whole building, but it usually happens. There is one unique circumstance in any building where there is that layer of ambition that like challenges the entire convention of everything we do. That's when you need the whole team. Yeah.
Yeah, I would agree that the method that it used to be that, you know, the architect brings it up to CD and then it's handed off basically whole hog to a CM or one of these companies to make it, general contractor, and then it's handed off whole hog to a fabricator, and that this is running in a timeline that just goes like this and never goes backwards. I mean, just stay out of complexity. So in our own experience, we need to work, and we choose to work with architects and general contractors that allow this sort of to go both ways, that are interested in using new and unique ways to get things done. We have foregone drawings completely on some partisans' jobs and all agreed to a 3D model, a physical model that represents where everything has to be in space, and just said, this is where it is. There is, when the client says, where's the drawing? We say, well, open the model and take a look. Like, that's what you're getting. So you need partners that are willing to have this come back the other way, that if everything is a change order, you're done. Like, you're done. So there are people that work this way, but then we are actively searching out individuals that don't work this way, that understand that when the sort of level of complexity that the three other panelists, like the three panelists other than me, are producing this complexity, and I, for the most part, am just trying to deal with it in some way, trying to, like, you know, wrap my mind around it. And so if they're not willing to sort of have a much more symbiotic relationship, then people are doing this. What's interesting is there's no formal, you know, you're always doing it kind of off the books. It would be interesting to see if there is a kind of methodology, a more inherent construction methodology, kind of like Design Assist, where the fabricator is allowed to jump into the design a little bit. Is there a kind of version of that where the CM, GC, fabricators and architects get to live sort of continuously? It would be interesting. I haven't seen it.
I mean, that's what we were aiming for, you know?
that's the end goal.
So
well, I think we're seeing more and more of that, right? Like, I think there's places like Z Modular, I think Intelligent City in Vancouver and other startups are trying to see the potential of actually them being the fabricators themselves and being able to deal with all the different stages, because I mean, the amount of IP that, you know, I see the word for Mark, the amount of IP and intellectual development that needs to go in to make these things possible. I mean, there's a lot of value there that, you know, some of that profit goes somewhere else. And I think there, in some scales that might not be possible, but I would invite, you know, young offices to really take advantage of that. I think the integration at this sort of more standard level or more conventional price is still happening. Like, my partner used to work at Nippers and Helbig Engineering in Stuttgart, and they have architects in their engineering office, and then that was kind of essential for their projects. It's still a bit of an exception, but I think those things are the norm for that scale. I think for smaller scales or for other markets, I think the capacity for us to also take more ownership on the, as I said, I was a contractor and I can see the design build was fantastic, right? And there's a reason why all the residential market has kind of trickled out away from architecture discipline as itself. So I think there's a lot more potential to grow. And the emerging markets in Asia, they have an appetite like we have never seen before, right? To provide solutions and provide an integration in terms of design, fabrication, and execution that I don't think we have ever encountered before.
So on a small scale, Nick alluded to this, but we're currently working on using the HoloLens. We're collaborating with Hologram, an Australian-based company, to, and it'll be actually presented at Smart Geometry next year. We're anticipating this year, but they've moved it 1 year. But essentially we're fabricating, being able to essentially hand off a digital drawing in mixed reality space to a fabricator so they can build a complex object. In this case, we're doing an English wheel, which is not a naturally easy process to learn to begin with. So we're taking some ambition to that and seeing if we can essentially give digital precision to a process that is very easy for a human to take and learn and know all the little quirks that come along with it that might not be so easy for a robot to be able to be programmed to do.
This is where you're talking about a real mix of actual computers and humans, actually, which is like a whole other conversation, to be honest. We tiptoe around this using projection often, where if we don't want to have 8,000 drawings for 8,000 unique parts, we'll project that shape onto a piece. What you're talking about is screw the projector, screw having to have flat objects. Like, you get to live in a theoretical space and then just start to put it together piece by piece. Could be very interesting, I think. I wonder if you guys have any sort of construction partners that are, I mean, obviously we're interested, we're chatting with you guys, but I think there's a big market for it.
Yeah. I mean, ideally we would have liked to do this with Gusto beforehand, but.
I know, could have been a cool application for this exact technology for sure.
And I think one thing that I would like to point out is that if you look at Joris Larman or what used to be the 3D printed canal house, those were architects who went from designing things to actually making things and creating their own startups and businesses that are actually thriving in their own right. So, those kind of early, for some young practices, one project can actually not only be a successful enterprise, but it might also be the onset of other opportunities, business opportunities that actually can. Because I mean, we're uniquely positioned to do that, right? We're uniquely positioned to think of these interdependencies, and we're uniquely positioned to even sell the product because we understand what it is the kind of value that these opportunities may provide.
I'll add one thing. I'm like biting my lip because I had a conversation internally with another colleague of mine the other day. I almost don't want to say this publicly, but we were just talking about the notion that why do things move so slowly, right? Like we have, I personally have, as being an individual who kind of just like adapts very quickly to things and absorbs stuff like a sponge and moves to the next thing, working in a profession that is like molasses can kill you some days because it just like mentally breaks you down. And, we were just having this conversation where, for all the rights or wrongs, I'll use an example of a company like, say, Apple, for instance, where obviously, you're selling a product to someone, you probably don't want to tell them that they have no idea. I mean, even though the reality is that they have no idea, you want them, your sell to them should not be, we have all the answers, but whatever, let's leave that aside. Is that they don't ask questions. They just go and they do stuff, and then they say people will realize, right? And I wonder if our profession is actually at the point in history where it's kind of like, if we just go and do stuff. Now, of course, and the reason I'm bringing this up is because the question is, as a team together, if you can get a team together, can just go do stuff and just start operating in the future, maybe that's the incentive for everybody else in our industry to just say, shit, they just like leap yeared us by like 1 million years. Holy hell, we gotta pick up our game, right? And so I'm sorry, I'm like throwing a question out there and inciting maybe a riot, but this is like some of the conversations I have, like existential questions I ask myself internally constantly, and with some of my colleagues, is that maybe we should just like go do this. Like, let's build the team and let's just go make the future, which is part of what this conversation is supposed to be about, right? So anyways, I'll throw that out there.
Mark, you're spot on. I think that's a really, really good and compelling sort of call to action. And we've seen a little bit of this even in academia, right? Like, there's some places where some of these research, ETH, which you brought up, is one of them, where, you know, they didn't know that this was going to take up the way it did. And that small, Fabio and Matthias, they started this, Germasio and Color, they started this kind of thing in a very small scale.
Right.
And one robot, you know, which is not a big investment. And out of the blue, this is now this massive center for innovation with multiple industry partners. And it wasn't because it was sort of given to them, you know, they just kind of initiated, and it has grown, right? And so some places in academia, and I can speak from my own experience, some places can be extremely reluctant to engage this. And I think architecture is also extremely reluctant, but if there is a place to change, I think that opportunity is actually lies with us, the responsibility lies with us. And I very much appreciate your call for action. That's where I stand as well, even in academia, let's put it that way.
Yeah, and on this note, I think we should keep this conversation going. And, you know, we have some channels, I think, you know, like, first of all, this Toronto Dynamo user group or the Toronto BIM community, I think we should stay connected either by Slack or what, you know, we have like virtual meets right now. And I don't know, what do you guys think? Like, you know, like just try to collaborate or collectively think about it in a way like this, I don't know, and be a little bit more practical.
Yeah, I think what's interesting today is what I like, what is kind of inspiring is the fact that somebody that is making stuff is here too. I used to be that person as well for a period of time in my life. And so again, I think it's like, it all kind of, and I know I've said this a couple times, but it all kind of starts with making stuff to make better stuff. And so what a kind of crazy notion that I had that some people kind of freak out when I say it out loud is the fact that I think and this is kind of, I guess, is piggybacking on the last kind of conversation or your question, Patrick, about, you know, teams and whatnot, is that I truly do feel that at some point, either architects will become, let's call it architects, engineering, whatever, are going to become the makers, or the makers are going to buy the engineers and the architects. And they're going to be, it's going to be one thing where it's just kind of like, you know, you're like an amoeba that just, you attack something and it's like, we're going to eat it up sort of thing. Right. And so that convergence is going to happen. It's happening in China. There are companies in China that do it already. And I would advocate on the side of the question I would have as an architect would say, how do you uphold and maintain the integrity of design and what that means if we get swallowed, because let's face it, they got more money than us, as opposed to, you know, just doing things economically, right? So I don't know.
I would say, as a person that left architecture for fabrication, that you guys don't have to be passengers in this. That space is sitting, waiting, ready for you to go make that change. I hope that in my own small part, when I showed up to MCM, there was so much knowledge. You know, Gregory Ryback, our owner, and a couple of other senior project managers, a guy named Jack Debsky, and then also obviously 200 makers in that space come with 25 years of experience. They know exactly what they're doing. All I added to this was basically Rhino and Grasshopper. Like, I just knew a couple tools and a couple people. I was not an expert in parametrics. I wasn't even a particularly good architect. I mean, I was a passionate student, but I just had the level of my engagement was high, my excitement was high. I want every problem I saw, I wanted to attack it. And I see that in the industry, there's a kind of like, ooh, like, I don't want to get involved. I'm going to lose money. Everything's about the bottom line. If we can like shrug this thing about money, convince owners and clients that this computational method can be accomplished at a lower cost, and then go and prove it and show to them that it can be done at a lower cost, that's what will happen. And I think we're doing this every day. I don't think it's so lost. I think that even in Toronto, this marketplace with not too much excitement, I've spent the last 10 years sweating out some very ambitious work from architects. So it exists here in our local communities, and all we have to do is keep fanning the flames, stay on top of it, keep pushing hard. You don't have to be architects. You can also be fabricators. You can also be engineers. You can do whatever you want. And then and then just keep, I would argue with you, we all together have to keep pushing everyone to get there. I think we're getting there. I really do. I'm not so pessimistic.
No, I'm not. I'm not trying to be pessimistic, but yeah, it's a challenge. It's a challenge. But I just think that the mind of the engineer, the architect, is built in such a way to do two things. First of all, question everything, which is, you know, usually costs a lot of time. But the second thing is just the way that thinking goes down. I think that it's actually a really positive thing for that fusion to happen, to be quite honest, because it's like the best of all worlds.
I mean, I always use the example of car design. I mean, it will be inconceivable that we were somehow design a car and then send it out for tender, right? Like that's just not, it just will never happen, and we wouldn't have the same efficiencies.
That's a really good point.
And if you actually look very carefully at the top manufacturers, I mean, Mercedes-Benz is hiring architects, right? BMW is hiring architects, both to design vehicles, to design interiors, to think, but also to think about materials, to think about new technologies, to think about new ways of improving. So they even see the value on us that I think we need to ourselves identify as, you know, as Mark says, you know, it's not a bad thing. It's actually, this is a critical step for us to move forward and realize the value that we can provide.
Excellent conversations, folks. I think we should end, right, Claudia? Did you want to say something?
No, I was just going to thank all of you. We've had such a great conversation, and we wanted to do our closeout, and we're aware of the time, and I'm sure everyone has lots of meetings. Thank you again to our presenters, and I'll pass it over to Patrick to close out.
Yeah, so I have a couple of ideas how to practically start diving into digital fabrication. So here's a list of fabrication labs in Toronto. So for those of you who are not working in offices that are, you know, that are equipped with digital fabrication workshops, 3D printers, or CNC milling machines, you can start exploring these. We're gonna put them online on our webpage, and we're aiming at creating a more comprehensive and, you know, a list of those places in Toronto. But I think it's a good start. Then we have firms designing for digital fabrications that we know of. And if you're here in attendance and you feel omitted here, please type in the name of your firm in the chat, and we will add it to this list, or just get in touch with us. So, you know, we have Damen and Schmitt who are here today, Partisans, HOK, but we know that IBI Group is doing some digital fabrication, Turner Fleischer, Intuitive is digging into that, and Dialogue. We have Fabricators, MCM 2001, and Future Walters that I know of. Again, if you're here and you want to be added to this list, please do that. We're going to post it online after this. Conferences and workshops, they've been mentioned during the conversation. So Fabricate 2020 is going to be hosted virtually. It was supposed to be in person, but due to COVID, it was postponed, and it's going to be virtual in September. But you can also go to their website and download their free publication, which is an amazing resource. If you, sorry, David, you wanted to say something?
Yes, I was going to say there's the workshop, the robotic fabrication at the Center for Advanced Wood Processing at UBC, taking place in February.
Okay.
That's something to consider. I also want to mention for a key partner for us has been Perkins and Wills. I know they're also really pushing into fabrication and developing their own skill. They're also been joining our workshops as well. And also keep in mind that reach out to the universities. I know Ryerson is developing a lot of capacity, and they're very eager to build partnerships. I have been in conversation with Nicola several times, trying to kind of find better ways to have synergies, exchange with the students, get them an appetite to work with it. And in reverse, to also test ideas. If practice comes with that, we have the MyTex approach where we can partner up. We're also working with Autodesk. Autodesk has been fantastic at sort of opening opportunities for students and practice to figure out ways to troubleshoot ideas, test equipment, and work together in many ways. So
totally.
There's a lot.
Yeah. Autodesk is also open for partnerships with private practice. So I think HOK did it. It's called the Residency. So you can, we're going to put it online as well. And then future events. So we were hoping, this is going to be turned into a series. And the next one will be on, I mean, vaguely defined. It's in planning. So it's going to be on computational design and climate change. A little bit, talking about a little bit of addressing the ongoing ecological emergency. And as we see, everything is integrated here. So it's probably also going to be a little bit about digital fabrication, computational design, and in this case, the climate. We're hosting our user groups. This is something we do regularly, but we're also planning to do workshops and hackathons. And so this event was brought to you by Toronto Dynamo User Group and TBIMC. And yeah, we're almost there. Oh, okay. We have a little bit more time. We did a good job on managing time.
I just wanted to add, if people like businesses or people on this call are actually looking for, I don't want to call it free money, but let's say free money, things like Shred. I'm sure Nick, I don't know, like there's a certain scale of organization where it becomes untenable and it becomes not worth the actual investment, but stuff like the SR and ED from the government is a good resource for funding. NSERC grants with institutions, scientific-based institutions for research and investigation is also another good route for businesses looking to partner, because you can get tax credit, as David mentioned, MyTax. There's a lot of avenues to kind of explore and fund this without having to spend your own corporate dollars, especially if you're a mid to small size company.
Yeah.
So
for the next year, we're taking advantage of government funding to take on a larger number. I mean, we started a co-op program basically. So if there are any architecture co-op or even design or engineering co-op students that are interested to learn more about fabrication, please reach out to us. We are here. We'll be taking students every semester for the foreseeable future.
I was going to mention, I mean, there's still unanswered questions on the list, and I was going to say if there's anyone who's interested on the smart materials, looking at how you engage with those systems. I'm not sure about the rest of the speakers, but feel free to reach out via email or via LinkedIn, and we can have that discussion and try to guide you into the best way to move. I think we're all actually extremely open. I have worked with Mark and Nicholas, I know Ben as well. They're all kind of very open to sort of, we're all working on this together in many ways. So we're very much transparent and trying to make sure that everyone succeeds. The one about BIM in digital fabrication, my perspective is I don't see a difference between sort of the computational models that we use, because that's ultimately information. It's a model and it's just different scales. So I think the challenge is how do you, what scales are you managing? What type of data are you managing? How that is helping you design and what is helping you make those design possible. And that making it possible goes anything from the financial end on the business end to make the things possible and those matter, how much volume you have, how much surface you're milling, all of these details really matter, and understanding what information needs to go where, how do you manipulate it, how do you control it, and how do you make the most out of it. It helps you make the best decisions. That's what you can work with.
I just want to add to that I spent the better part of a year explaining to a client that BIM is not a three-dimensional model, that it's actually, it's like the collective assimilation. It's actually more about the eye than it is about anything else, but it's about the collective assimilation of data that ultimately, and the way that data is represented could be in multiple forms. It could be Excel spreadsheets, it could be databases, it could be three-dimensional models, it could be two-dimensional lines. It could literally be absolutely anything, but it's the collective composition that actually is what BIM is, and that people should not confuse the fact that a 3D model equals BIM. Sorry, I just want to add that.
And I'm looking at the comments as well as someone is mentioning Algonquin College in Ottawa or Z Modular. And one of the things that I always, even when you go to one institution, whether it's school or a practice, or you go to Nicholas' sort of workshop, is that it helps you demystify what these tools are physically and computationally. And then it allows you to even understand what is possible, right? Like, I think we sometimes kind of keep too much of that distance, and maybe we're too timid of reaching out. And I know for a fact that many universities and many places are more and more open, because that discussion is really essential in making these projects a reality and making better decisions.
One thing I wanted to say, that's a fantastic comment actually, is I think in the spirit of openness, I'll certainly say that for us, when we create, because you mentioned, actually David mentioned some IP at certain points, right? I think kind of what's, when you consider IP, the idea of what classically has been considered IP is a lot different now than it was historically, right? People used to say, oh, you made a script, you made software, let's lock that down. We don't want anyone else to have it. to be quite honest, really, like, who cares? You have to know how to use it, reverse engineer it now anyway. So it may as well be free anyway. By the time people figure it out, you've already invented something else, right? I mean, that is the reality of the situation. So, I mean, I know that internally, like, we just, like, a lot of stuff we give out for free, right? We have Mission Control, which is it's a platform to, like, do stuff with BIM, to be able to manage a BIM model. So these are some things that we've just realized that I think, again, it's process derivatives that are, like, of most value, because they're the ones that save you all the time and enhance things exponentially. So I just think the idea of, like, as a society to kind of, you never know, I guess the point is, you never know what you're going to get from somebody else that's going to help you solve a problem. And so it's kind of just good karma to contribute to that economy.
Absolutely.
Right.
Absolutely.
I think good karma is the right word for it. I think that more openness and more collaboration is actually what's required.
Yes.
Right.
Thank you so much.
Yes,
So,
thank you.
I just wanted to thank everyone, to thank panelists for participating, to all the attendees that were here and participated in asking questions and comments. And I wanted to thank you to sponsors, and also to everybody who actually contributed to the organizing of this event. And I hope we will see you soon. We will see each other soon, like either during our next event, or like some, interpersonal communication that's going to be happening after this event. So, yeah, thank you, folks.
Thanks everyone
Thank
for
you.
coming.
Thank you.
Thanks, everyone else.
Bye, guys.
Bye.
Mhm.
Bye.